Hello, I hope you are able to hear me. So this session will be about C++. Uh, so basically, thing that we would try to do today are like, so basically today we will just try to get into C++. We'll try to understand the all the necessities that we would need if you want to use C++ to build any project. So basically, I would call it as like call it as knowledge regarding modern C++. And then onward we would get into advanced C++ uh, tomorrow, and then on day after tomorrow we would work on like we would go through Calvin filters, we would code it using C++, and then on 22nd we would do sensor fusion. So that would be like agenda that I have at my end. So let's get started. So first of all, let me share my screen. So this is the folder that I created yesterday. Okay, so you could see it. So basically, these are the things that we would be doing. We would get started with like basics of like C++ programming language. Then we would see like how exactly we could define constant inside C++ programming language. Then we would see like how exactly we could take in input from the command line, and then how can we like display them back to console. We would also try to go through like few of the data types that are available inside C++, and we would also try to learn about control flows. Then we would get into how exactly arrays can be defined inside C++ programming language. Then we would talk about pointers, basically, which are like variable which store the address of another variable. We would look into it. Then we would look into vectors and vector library. Then we would talk about functions and what all types of functions are there. How can we can write a function which can means which are called by value, called by reference, and in some cases we could also use pointer. Um, so pass as a pointer. So that would be like our thing. And then onward we would go to like a tutorial related to class. So how exactly class is being defined. So you could see over here. So this is like main file, and these are the dog.hpp and dog.cpp. Basically, these are the dog is the class that has been defined, and this is header file where like all the method relevant to that class are declared, and dog.cpp is a file where these methods are defined. So that's about like tutorial number 10, where we would learn about class and like all the main pillars of object oriented programming language that are like encapsulation, abstraction, then inheritance and polymorphism. Then we would go further and we would talk about like overloading operators, how exactly we could like overload the operators. Basically, this is something quite related to generic programming. So we would also try to touch that part a little bit, like how exactly we could write function which are generic using templates. So templates for like functions and templates for the classes. We would get into what's the difference between prefix and suffix. So basically, this is something should be covered after like basics or constant part. But I mean, we would see like where exactly to fit that thing in. And once we are like done with this thing, so most of the concepts that are related to like C++ programming language would be covered. And then we would go to like few other tools that we would need to uh, test our code. That would be like Gtest. So how exactly we can write code using Gtest? So that's something you could see inside this tutorial. And when we write code using Gtest means when you want to write code inside C++, which would be tested using Gtest library, we need to create a pipeline, and for that so that's the one thing. Next thing would be to how can we use like build tools like Make and Cmake. So Make is a with which we could make like make file and build a code. But in that situation, the command that we need to give to compile our code will be like pretty huge. And to automate that thing, we have like another tool, which configuration tool for like Make, that is called as a Cmake. So first of all, for that purpose, we would need like the cmake list.txt file. So I would also explain how exactly we can write cmake list.txt file to run these test cases, and then how to generate make file out of it, and then how to generate like executable out of it. So that's the thing. And then over here I also added pointers for like chapter 1, chapter 2, chapter 3 from my like coursework. So basically today we would try to get started with chapter 1, and then we would get into like all of these other things. So first of all, you would not have this thing available on your system. So what you need to do is you need to clone this thing on your like system. And for that purpose you could simply use like git clone, and I would also share like link between git clone and then the address that I would share with you for that git repository. You have to paste that over here, and you could clone that thing on your system, and then you could get access to all these files over there. Okay, so now I have like all of those things on my system. What I would do, like, probably I think I should show it. I think I must show that thing to you. Okay, so I would just come out of this folder, uh, and then I would make one directory, uh, test. So now over here I will try to clone that C++ repository. So yesterday I believe I shared something. So this is a repository that I have created. You could also fork that thing on your system. So you have to git clone, and then you have to paste this link that I will be sharing with you. And once you do this thing, all the files would be like earlier when we test this, check this testing, means when we created this test folder, there was nothing inside the directory. After cloning, we have like all these files over there. Okay, where am I? Yeah. Uh, so inside advanced CPP practice, um, we have like all the things. Okay. Probably came inside another thing, but yeah, that's fine. So this is advanced CPP practice, something you would be getting on your system. That inside the directory, and over there you would see like all these files. Okay, so to run them, what you need to do means to see. So you need to open that thing as Visual Studio Code Editor. So in my case, means from Linux, I could just open that with like code and current folder. That's like a period symbol. So that would be open with the VS Code. Actually, when you want to start software development, there are certain tools that we want to learn about. First is like what would be our code editor. So in my case, the code editor that I'm using is a Visual Studio Code, and this code editor is quite easy to use. You just need to click on this file over here. You could create like new text file or new file or whatever format, or you could open other files and formats and all that stuff. Okay, so that's the one thing. So first thing that we want to learn is like what would be our probably I should also keep note of all the things that I would be studying. Okay, so I would just go to chats and I would write it down. Chat wouldn't be like appropriate way, maybe. So first of all, we would start try to write about code editor. So first of all, whenever we are going to develop in the software, we need to use code editor, and that would be like VS Code. It would also act as a debugger. Second thing that we need to look into is when we have like this Visual Studio Code as a code editor, next thing that we have to see is how exactly we could compile our code. And for that purpose, the thing that we could do is we could use like inbuilt compiler, and that would vary from like operating system that we use. So for Linux, it's like G++. For Microsoft, it would be different. For Apple systems, that would be different. Okay, so we would have like different sort of these compilers based on the operating system that we use, and we have to choose that thing. Okay, in my case, it's a G++ compiler or GCC compiler. So I would be using that thing. So, but that's the second thing that we would need when we write C++ code. Compiler, that would be like G++. Then third thing that we would need is like so compiler is something would help us to compile our code and get that source code and convert it into executable. But when it's like simple source file or single thing, it would be easy. But when we have like big project with us and when we want to compile that thing, then that would be like a tremendous task. And for that purpose, we would need to use something called as a build tools. So the one popular build tool available out there is like Make. So for this tool, you would need make file. So that make file has to be written, and inside that make file, we have to list all those things like what source and directories and libraries and all that stuff executable. So we have to mention everything, and then only we will be able to like build our project using that make command. So that's like a build tool. And since this build tool and this make file is quite complicated to write, another way around that thing is Cmake. Cmake is basically a configuration tool for the build tool. Configuration tool for build tool. So basically, and for that purpose, what we would need Cmake list.txt file. So basically, we would need to write down the cmake list.txt file, and the cmake list.txt file is something we could build, and with that we would get this make file. Whenever we type like cmake, let's say we have a project, inside that project directory we would have like cmake list.txt file, and whenever we write cmake cmake and current folder, it would find that cmake list.txt file and it would build it, and we would get like make file. The next thing that we have to do is like we have to take this we have to build that make file. So that make file would have like mention of everything, like okay, what is the source code, what should be like executable name, and what all libraries to include and all that stuff, executables, libraries, and linking and all that stuff. It would happen using that make file, and we would get like executable, and that's something we could run the way we run in other cases. But this is the fourth tool that we would need when we want to like build any software using C++ programming language, like the Cmake thing. We would also look into that thing today. Then next thing is testing. So for testing our code, there are various tools that are available, but the tool that we're gonna use would be like Gtest. So using Gtest, we could like test our code very easily. So our code can be checked for logic, uh, and so logic is something we could check. We could also check like syntax check is something already being done by compiler. So during compilation process, there is like lexical analyzer, then synthetic this syntax analyzer and semantic analyzer. So those things would like take care of that thing. But with Gtest, we could like check logic, whether the piece of code that we have written gives accurate result or not. That's something we could check with Gtest. So we would also see that thing with today. How can we write test using Gtest? Sixth thing is coverage analysis. So coverage analysis is something we would not cover today, but I could just tell you like the tool that we could use for that purpose inside Convex, and it's the Gcon. So using this tool, we could like perform coverage analysis. So whenever we run test, we could check like what all part of like code that are being checked, and based on that we would get like report inside like in the form of like HTML file that we could like run inside browser, and we would see like what part of code is being checked. So these are like 6-7 tools including debugger that we would need, and there's one more tool that I forgot to mention is like version control. So version control is something that can be handled using Git or GitLab. So this is the seventh thing that we would need, Git and GitLab, and I believe like I created like video related to Git and GitLab last time. So if you go through that video, you would understand like pretty much most of the things that we would need to handle stuff using Git. And then last thing is like the capability to deal with Linux operating system and bash files. So write these bash files. So means what are the what are the basic Linux operating commands, Linux operating system commands, and what is the bash file and all that stuff. So basically, if we learn about like these many things, we are good enough to go ahead and work on any C++ project. So these are the tools that we would need, and we would look into each of that tool step by step. Okay, so let's get started with first thing. So first is a basic CPP. But before going over here, I would like to explain something, and for that purpose, I would go back to that directory that I mentioned about. So basically, this is the directory that I have. Once I shared with you, you would also be able to see that thing in like browser. So over here, I have added like little bit description about like that entire coursework that I'm taking at Advanced C++, and what all things that we should be studying to get up to level and start developing project. So these repositories designed and developed to help beginner to get thorough understanding about C++ programming language, including topics from the basics of C++ to the advanced and modern C++ concept. So this is the thing, and this is the concept. This is the content that we would be covering at least for today. The onward, like, means we would be updating it further as we cover like more topics of advanced C++, like smart pointers, then resource acquisition is resource uh, acquisition is initialization concept related to metaprogramming, concept related to parallelizing or threading. So these are the things that we would be covering later on, but this is the content that I have in my mind right now. So first is the basics of the compilation. So you could just like read it out and like you would understand what all things that are there, but still I would try to walk you through what all things are there. Okay, so basically there are two types of programming language. If we take like any kind of programming language, there are like three types of programming language that we first of all understand. Okay, so first is like high level language, then there are assembly level language, and then there are like machine level language. So high level language are the language that human can understand. So C++, Python, Rust, then Java. So all of these languages are like human level language. And when we write code inside this language, human can understand that language, okay? Because that's quite similar to what we have in our languages, okay? Like the language that we speak. Then there are assembly level languages. So basically they deal with like assembly code. And then there are like machine level languages, which deals with like machine level code or object code or like byte code in the forms of zeros and one. But this code is something hardware would understand, and it would give like appropriate instruction to a microcontroller or like whatever processors that there to take appropriate action, and our work would be done. So our task is not at like machine level language, not at like assembly level, but our task is at like high level language. And there are like two types of language at the higher level. First is interpreted languages. So interpreted languages are the one which are generally interpreted by the interpreter, and that's like Python, where source code and inputs would be taken and that would pass to interpreter. So interpreter would like compile and execute them at once and give us output. So basically just interpreting the source code and giving us output. So it's not like it is converting first into like executable and then running it. It's not like that. It's doing all of that at once. So these languages means you don't need to compile them, okay? And they're like pretty good. Means programming inside like this interpreted language is quite easy. But issue with these languages is like these languages are slow, because you when you write code inside that language, you don't, since these languages are like dynamical type, means you don't define type of variable that you will be using inside your code. So you don't know like how much code, how much space you would need on RAM or like means on both the segments, okay, on stack and on heap. So you need to see like how much code you would need on both the sides, how much space you would need. So and there are like other issues, okay? So because of each these languages are like slow and they're dynamical type, so they are like easy to write, but issue is that like they cannot be used for like safety critical applications or like where speed is really important. That is the reason they are just used for prototyping purpose, and prototyping purpose means like they are just used to test whether the logic works or not. And then there are like compiled languages. So compiled languages are the one where source code has to be compiled first into executable, and then executable has to be run by um, our system, and then we would be able to see the result. So when we talk about the compile language, there is a whole procedure that happens. So in case of the compiler, means this compilation process, what happens? First of all, we have like preprocessor direct means preprocessor. So when we write C++ code, like .cpp code or .hp .cpp code or like means other means I'm just talking about C++, but you could also have like code inside C. So when we like talk about that code, so there would be like some libraries that we include inside preprocessor directory part at top, and then there is a main function, and inside that main function you would be writing like certain comments or like uh, or doc strings, and using that we would try to give some information about code. So that part would be removed. So first of all the library that are included, those libraries would be expanded. So that's first part that would happen inside preprocessor. And second thing is all the comments that are being added, so those comments will be removed from the main code, and then that code will be further fed to the compiler. Next, compiler would be there, and what compiler would do is compiler would take that source code and that would try to convert it into assembly level code. So that's the second task. Okay. So inside the compiler, there would be a lot of things that would happen. So first of all, what happened is like lexical analyzer. So lexical analyzer is a tool or like step where like code would be taken, it would be converted into tokens. Then there would be step. So basically those tokens would be created, and from the tokens tree would be generated, and based on that like further steps would happen. So basically first is like this lexical analyzer. This is how like code would be converted to tokens and then like arrange in the form of tree, so that we would understand, okay, this is a flow in which we have to execute it. Then second thing is we have like the syntax analyzer. Syntax analyzer is something would check those tokens against the predefined tokens, and it would try to understand the syntax error. Then that code would further go into semantic analyzer, and semantic analyzer would try to find semantic errors inside that code, and then it would go to like this intermediate code generator. So basically this is a stage where we have like this assembler, and then assembler would convert that code into machine level code. Then we have like this so this is like third step, assembler, machine level code. And then over there we have linker. So basically we get like machine level code at the end of like third step. And thing is that since we would be using like a lot of libraries, the object code that we would be getting at the end of like assembler step, that would be different for each of that libraries. Okay. And we need to we need to combine all of them together in a such a way that they would work together properly. And for that purpose, what we need to do, we need to make sense of all those object code that are there. Okay, and for that purpose we need to establish the link between our object code and like those libraries API, and for libraries, and for that purpose we would be using like these APIs, and through which we would make sense of this object code that have that is there related to that library, and that would be added with symbolic addresses, and that's how we would get like executable. And that would be further can be optimized, and then you would get like final code generation. So this is like procedure for the compilation. And once we get like executable, next thing is we have loader. So basically we would take those symbolic memory addresses and we would replace them with actual memory addresses, and we would put that entire source code on RAM, and then it would start executing that source code. So basically that's like running the code. So this is how like this compilation and running happen for the compiled languages like C++. The thing that we should understand over here is like this is a machine level language. That's the reason it's fast. Second thing, since we are first converting like checking our code for like errors, so it's like reliable, means can be used for like safety critical application. Second thing, it is like statically typed. That means variable type has to be defined before it is being used inside program. So that way we get idea about how much space we would need inside memory, and that's the reason it make like our operations quite simple or like easy. Like we would understand where exactly we have to fetch our data from and where exactly we should save it. So these are the things about like this entire procedure about what all languages are there and what is different interpreted languages and like these compiled languages. And C++ is one of those languages. C++ is compiled language. Okay. Now we will try to understand the code structure for C++ programming language. For C++ programming language, we can split our code. It's like main file. This main this .cpp file can be split into two parts. First is a preprocessor directive. Preprocessor directive is a part where we could add all the libraries that we would be using inside our main function. That's the one thing that we could do. We could also include certain macros inside preprocessor directives. It could be inclusion guards. It could be to like define certain constants, or yeah, means these are the things that we could include inside preprocessor directive. And then second part would be main function. So main function is the part where like our actual code would be executable. Okay, so whenever we run our executable, so this main function is something, or whenever we run our code, this main function is something would be executable at that time. And based on the like sequence of the lines inside that main function. So main function is like a function which returns 0 as like integer values output. and it implements like entire part. And inside that main function, what we need to define is we need to define variable type like integer a, b. So a and b are the variables that we would be using, but we need to specify what would be like type of that variable, like integer. Then to write to the console, we could use like this. Since we are using like standard C++ library, we could use like the cout statement to write to the console and C to read from the console and then return 0. So this is the main function that we have. And these are the two parts that we have inside C++ code, okay? Like preprocessor directive, where we would include all the libraries or like classes that we would be using. And second thing is the main function, where we would be executing our main part or like main objective of our program. Once we are like done with writing that source code inside this Visual Studio Code editor, what we could do is we need to compile it, and for compiling we need to use this instruction. This is the format that we have, okay? And then once this compilation is done, we could just run it, and we would provide inputs and get out. So that's all about like C++ syntax that we have. So let's now try to get started with the first code that we have. Okay, so that's something, this is something where we would understand about like C++ structure, I mean C++ program structure. First is the preprocessor directory, as I mentioned. There would be like hash. So basically that is a keyword. Hash includes a keyword that tells us like what all libraries would be included. So when we include them inside this angle bracket, that means like that library is part of like standard library of CPP. And there is another way, means whenever we have to define like whenever we have to include any class, so in that situation we could use like double inverted commas instead of these angle brackets. Basically that tells us like that code is like part of current directory, okay? That's something what happening over here inside this 10 class. So this thing is just to tell this, okay, this doc.hp file is part of this current folder, okay? So we have to include that there. And then second part of code is a main function. So inside this main function, so we have to write like this int, the way we define function. So int is like output type of that function, main is name of that function, and that would be same. And inside this parenthesis we generally don't provide anything, but if you want we could provide like number of argument and value of those arguments, like int argc and character stars argv. But then after that, what we could do is like inside this curly bracket. So curly bracket tells us like span of our program. So basically inside C++, we try to uh, combine inside Python, we try to uh, cluster like I mean same part of the code, or like I mean similar statements using like this what we call it space, okay, at the beginning, indentation. So using that indentation, we try to group all the similar segments together. Inside C++, we use this curly bracket, and whatever is included inside this curly bracket would be part of like this, means would be executed, and would be saved. Once this curly bracket is like closed, that means all the saved values of like A and B would be gone. Okay, so that would be like this. I mean, that is something we call like um, global and like this local context. Then second thing that we have to consider over here is whenever we have to terminate any particular statement, we would use semicolon inside C++ programming language, and then we have like command to write to console and read from the console. So in our case, we have like this IO stream. So IO stream is something library tells us, okay, this library something would help us with like reading inputs from the console and writing to the console. And for different purpose, there would be different libraries. So hash include IO stream would be like first line of the code. Then using namespace std, as I mentioned, we could include some macros. So using is just something with which we could also define like certain variables. So we would be including this standard library over here so that we don't need to write like standard colon cout each time. Okay, we could just write like cout, and that would be like enough. So these are the two things about preprocessor directive, and then there would like main function. So this code is about like taking two variables, integers, and summing them and giving out that output. Okay, so I have defined these two variable a and b. Then I have given, means I am writing to console, enter the value of a, and this is like a step sequence that you should keep in mind. Okay, /n, so like that means like new line, and then this is end l. Okay, so like ending of the line. then cin to read from the console, like I'm reading A, then enter the value of B, reading B, and then I am means this is addition operator, this is like arithmetic operation is being done, and then that value would be stored inside C variable, that would be like integer, and then I am giving out value of C to the console again and returning 0. So basically this tells us, okay, this main function has been implemented and I am returning 0. When the 0 is returned at the end of this main function, that means our code is executed properly, okay, without error. So this is like kind of check to tell, okay, this means program is working fine. Okay, so when we are like done with writing this code, the next thing is we should be like compiling it. Okay, and for compiling, what we could do, assuming we are in that same folder, we could write this command g++, that's like syntax for the compiler, g+, this is a compiler, something I would be using. Then I also need to tell, okay, what kind of means when I would be compiling, what all rules that I should be considering. So I want my code to be in compliant with like C++11. So I would be including that thing with the stack standard C++11. Then I need to mention like source file. So source file is one basic.cpp. If I have like some class file, you could also be mentioning that thing, but .cpp extension. So one underscore. So that something is done. So basically this is how we would mention like what all things that would go into as inputs, and then we need to mention like what should our how exactly our executable output should look like. Okay, so our executable file should have name, same name. Okay, one system has done pretty slow. So I have like named that executable as like one underscore basic. So when I run this, so it would like compile my code, and now you could see like there is executable. And to run that executable, what I need to do, like current folder, and then inside that current folder, I need to write, okay, one.basic. And when I enter, so it says enter the value of A. So I say like 23, enter the value of B, 5, and value of C is 28. Since we haven't, okay, so this is the value that we will getting over there. Okay, it's in the same line. So that's the thing. So this is all about C++. Means this is just all about basics of like C++, basic syntax of the C++ code. That's the first thing. Second thing is now inside C++ programming language, sometimes we need to define certain. I would just like, okay, in C++ programming language, in the beginning we would need to include certain variables. Okay, and for some variables, those values would not change, and those variables should be like global variables. And to add them, what we need to do, we need to use like various ways. So that's something we would talk about in this tutorial. So first of all, as usual, we have to include libraries inside this processor directive. First is hash include IO stream, so that you could read and write to console, read from and write to console. Then hash include IO manage. So this is like input output manipulation. So basically you could like set the width using standard set W width. You could set like output width for your output. IO manipulation. I have just added that library. I haven't added like any explanation for that, but we could decide. And then hash include string. So string is something, I mean, it's a kind of like custom data type that we would be using. So we need to include that library to standard string. And then we would be including certain constants. And there are three ways. Okay, so using define, if you have done like means courses related to embedded C, you would understand. Using define, we could like define certain variables. So define date of birth, like this is July 5th, 1995 0507. So this is like, this is a variable that I have defined, DOB. Then I could define like another variable name. Okay, so that would be like Mayur, using namespace std, so that I don't need to write std colon throughout each time. And so this is a one way of, okay, means using define and then a variable name and value. We could also include like this thing pi over there. Okay, define but for that purpose, I believe we need to include Cmake library. And if I write pi, so means I could also include value of like mpi over there. Okay. So that's the thing. Then second way to so using namespace std. So that's how like basically what we are saying is like our standard library would be series like namespace. Means so that we don't need to write standard cout each time. We could just write cout and still it would make sense to our compiler. Then second way is using type def. So type def is a keyword, and after this keyword we need to mention variable type, that would be float, and then that variable like name, or variable. So here we have to type like data type, and then here name of that means you could also create like custom variables over here. Okay, with just using this C thing. Okay, so it would not just be like one variable, rather you could create like multiple variables of that. Okay, so using like enum function, you could like create like variable custom variable of your own. So similar way we have like this type def float C. So we have created like variable C of type data type float. That is the one thing, and you could also create it using like this using d equal to integer. Okay, so over here first of all we include we have to, in case of the type def, we have to add like data type first and then variable name, and in case of the using variable name first and equal to then data type. So these are the two things that we have, and then we would have like this main function. Inside this main function I would show you like how that we could use it. Okay, so what I have done over here, I have defined integer a as a variable and means declared variable, and then I have defined or equated it to like date of birth. So integer a should have value of like this date of birth, and then string. So I have included like a string variable called my name, and that value should be equal to name that we define over here. The reason I'm trying to like equate these or like declare them as like one variable and equate them to like variable that we have defined over here, just to show you that like global variable can be accessed inside main function. We could also make certain function like certain variable constant so that their value would not change throughout operation. And over here we created like this variable d. Okay, so d variable of integer type. So even it's like 20.5. So means when we print it over here, you would see like means we would be getting 20, and means d is integer and c is like float, so it would remain same. Okay, so it's like data type. So that thing has become like data type. Okay, so it's not like we have defined variable. It's like we have defined like custom data type. So float is like a data type, and that means we don't need, whenever we have to use float, we don't need to define like it as a float. Rather, we could define it just as like c. Whenever we have to use integer, we could just define it as a d. So integer dd 20.5 c e3, and then I have just added some condition over here. Okay, when b equal to 2, c out is equal to means I should display the value of d and e. So value of d should be like 20 and all that stuff. Okay, and return 0. So that's the thing. Let's save it using control s. I could save it. I would go to a terminal, new terminal. Then again same syntax, local runish. No, I don't know. G++ standard C++11, then second output. So mpi is redefined. Okay, because that is already part of that system, so we don't need to define it again. But yeah, that's fine. So you could see like it is in file included from like C++ Cmake library. So means we don't need to define it separately. By default, it would be there. So in your operation, when you like add that Cmake library over there, you could just use it over there. Okay, so I would just save it as it is so that you would not have any like faulty code later on. And then I would run this thing, and you should be able to see like so 20 and 3. So the thing that you should see over here is like value of d over here is 20.5, but since we have defined d to be integer, we are getting value of d to be like 20 as an integer, and here it's a float, so it's like 3. Okay, even though we have defined it to be like integer, still it would be like considered as a float. So that's the thing about like all the ways through which we could define constant inside C++ programming language. So until now, what we have learned is like how exactly what would be like syntax of like C++ program, like this preprocessor directive and main function. Then what are how exactly we could read from the console and write to the console using C out, and what are the ways using which we could like define constants, or like what are the ways in which we could include some macro to define like custom data type. Okay, so so using define we could like include variables, means some constant variables over there and assign some value to them, and using this type data and using we could like define custom data types. So that's the thing. The next thing is using type def we could also add values to those variables. Okay, the next thing is we would try to understand what how exactly we could like operate on strings. Means when we have to operate on strings, like there is like different commands that we would be using, like if string, f string. Okay, so basically whenever we have to read from the console, thing is that when we just want to read using cin, we would be able to read just one character. Okay, we would not be able to read entire string. So in that situation, what we need to do, we need to take help of, or like when we have a document, we have to read it. So in that situation, we could use these libraries. So iostream is like reading from console, cnc out. String is like string. So basically, this is the library that would allow us to operate on string as if they are like taken from console. And then there is a string library. And whenever we are reading certain document, we could also use this like fstream, ifstream library. Okay, but means I will not get into like how exactly we would use ifstream. That wouldn't be like that hard. We just means we would be including that library, and then like we would be opening particular file using that library. We would be creating object and then opening that and reading line by line. So that's really not important. But what's important for us is like how exactly we would deal with those means in situation where when we are not reading document, but we want to provide like a string as an input. How exactly it makes sense of that? In that situation, we need to use like getLine command. So this is something I would show you. So first of all, you need to include a string library at the top. And then inside this main function, you would be like writing a command to the console. Okay, enter the string. Then we define like two variables, a string variable, a string type variables, Mayur and name. So first thing is using this getLine command. So getLine command takes two arguments. First is a cin. Cin is like the thing that we are writing in a console, and Mayur. So Mayur is like and taking it here, and then it would be storing it to this variable Mayur. Okay. So whatever I would be typing in console would be um, like storing inside this string called Mayur. And what I'm doing later on is like I'm using the string library that I added over here. I am creating like some object ss string ss, and I'm providing that Mayur as input to that string, so that whatever string or whatever thing that is stored inside Mayur would be sent to uh, that object, and then that object is something I would send as input to getLine, and then I would try to save that value to name. Okay, so means this is a way we could read it from like command line, or we could read it from like another string and we would like save it in another variable. Okay, and we could just like get first thing something like that using certain delimiters. Okay, but for now I would just try to take thing from command line, and I would try to save it in like a name variable. Okay, so I save it, new terminal. Output should be, just try to remove the CP code. Okay, so it's saying enter the string Mayur is an engineer. So this is a string that I have entered, and that string now what would happen if that string is something provided from console, it would save into Mayur variable, and then that thing would give given to this object. and that object would be given to this get line, and it will be stored in name variable, and this name variable is something we are sending out to the console, so we should be seeing same string. So we are seeing same string. Okay, so that shows like you could take particular string, means we could operate on string using this get line command as if they are, or whenever we have to take multiple things as input, we could just use like get line and we could save this in some variable. Okay, so even if it's not just like a string, I could like provide some numbers over here. Okay, and those number would still be like provided, I mean, save inside that string, and then I would just change data type and I could like use it later on. Okay, but this get line command is important. That's something you should keep in mind. Using that get line command, you could get like multiple things at once, means multiple character at once from command line. You could save them in like in the form of string, and that string is something could be used later on inside code, and you could get like multiple things out of it. So that's the third tutorial that we have. Then fourth tutorial is about data types that we can use inside C++ programming language, and about data types that we could use inside C++ programming language, and also about this thing, control flow that we would be having inside C++ programming language. Okay. So let's try to look into that thing. So inside C++ programming language, we have like certain predefined data types like by default, and there are like 6 data types. Okay, that I would tell you. So there are like 6 data types that are there inside C++ programming language, and those are like character, boolean, then integer, float, double, and wide. Okay, so wide is something I haven't explained over here, but I haven't added over here. But whenever you because for variable there would be no data type as a wide, but for the function would not sometime might not return something. So in that situation, wide would make sense. So that's the thing. But over here, this preprocessor directory part would remain same, like IO string, Cmake, and vector. So since I would be using vector over here, so I have like included that library as well. And Cmake, since I would be using certain like math symbols, or like pi and sine and cosine. So in that situation, you should include the Cmake library over there, and using namespace std, and then this would be like this main function. So inside main function, we have like data type. I have created first data type to be like character. So this char is a keyword, and a is a variable name, and this is like character m. Then string h, this is my use. So string is like custom data type. It's not default data type, but with this you could like save like multiple characters, and you could also see like this. It would also say like, okay, it's a character, means it is the array of characters which are like 6 elements over there. Okay, 5 this and then this starting element. Okay, then this is boolean. So this is like second data type that we have. Boolean is like, means it would have like value of 0 or 1. Okay, since it's 0 in b, it would save as like false. Okay, so this is like another data type. It would take like less memory. Okay, and then we have like third data type that are related to integers. Means we have like 3 data types actually related to integers. First is a short. Short is something whenever we have like very small integer to store, we could use like short. Basically, when we are doing like code optimization, in that situation, we could like make these changes. So whenever we have our variable will be taking very small value, we could use like short. Means where memory consumption would be of like 2 bytes or something like that. In that situation, we could use like short as a variable, short as a variable type, variable data type. Second is a int. Whenever means number of integer values quite bigger, in that situation, like up to like 42,798, we could use like integer. And whenever it's bigger than that, it would be it would itself be better to use it along as like integer data type. Okay. So short, integer, long. And for float, there will be again 2 types. For smaller, float, and for longer, it will be double. And then there will be like wide. So basically, we have like these 6 data types, default and 2 custom, string and vector, and like array. And there's a lot of things inside the standard template library, but these are the things that we would be using mostly. Okay, so that's the thing. Next thing is, so basically these are the data types that we have inside C++ programming language. First is we have like character, then we have boolean, then we have integer, then we have like float. So float is something where we would be dealing with like decimal values, and then we have like this wide, and then string and custom things. So Actually, float and double is something we consider double. That's why I said like there are 6 custom data types. Sorry, default data types and 2 custom data types. But these are the data types that we would be having in C++ programming language, and it's always better to have like a command over them or understand which one to use when. And we are just displaying them each one like new line. Since like all of them are like if I just keep it as like that, means all of them would be like added in like one line. So just to like have them displayed on different line, I've added like this escape sequence /n. Then there are like control flows. Okay, inside C++ programming language, sometimes we need to repeat certain operation, or we might need to make some decisions. So in that situation, we could use like this control flow. So first is like if else loop. So in this situation, we have a syntax if condition inside parenthesis, and then we have like this curly bracket, else if condition curly bracket else in condition. So we could add this else if as many times as we want. Okay, so we are checking whether C is less than D or not. If then this display E. If it's if C is greater than D, display A. If nothing about true, then else display B. Okay, so this is like if else if statement. So you could see that thing. Okay, so this is the first control flow that we have. So if I save it and if I open terminal and if I build this code, just run it. So I would just means you could see like means all the values that we added as inside variables of different data types that are added. And over here, since C is less than D, value of E has been displayed. Okay, value of E is EFG. So this value of like 1, 2, 3. So that's value of E that is displayed. Okay, that means our this if else if loop is working. Okay, next loop is switch case. In some situation, what we need to do is we don't need like we don't need to go through all of this else if situation. Okay, rather what we could means instead of like performing that conditions means each time, we could directly do that thing somewhere. Okay, check that condition and we can directly provide that condition as like input to this switch, and based on that particular case would be like executable. So that way we could make our code faster. Instead of using if else if loop, we could use like switch case and we could make our code faster. But again, it depends like how exactly we are checking our condition. Okay, if we are using if else loop to check that condition, then it doesn't make sense. But means if it's like simple thing, then we over here what I'm saying like okay, case should third is like condition case that I want to run switch. So syntax should be switch, then case that I want to run inside that parenthesis, and then inside curly bracket I would have like case 1 colon, and then again inside curly bracket C out A. If case 2 is true, then B, and if default, so case 1, case 2, and default. So these are the things. If none of these cases are there, since I'm saying like 3, so none of these cases are there, so by default Z would be displayed. You could see over here Z is displayed over here. Okay, so that's the syntax for switch case thing. Okay, so we have learned about if else if loop, then we have learned about switch case, and third thing is a for loop. So when we have to repeat particular part of like code again and again and again, first thing is either we could write that thing as a function itself. Second thing is the instruction principle, and second thing we could write it is like for loop. Okay, means so when we have to like deal with code which is being repeated again and again. So when for loop is something would help us to repeat that code for a certain number of times. Okay, and there are like various way in which this for loop can be written. Okay, so first way is so I'm writing some array over here. Okay, so type of means data type for that array, the name of that array, and this syntax like this square bracket, and inside this curly braces I've added like this 5 elements, and then I am writing this for loop syntax. So for loop syntax would always be for means for, then inside this braces we would have like initialization, like integer I initialized to be 0, then semicolon I condition would be checked as long as I is less than 4, and then increment. Okay, so we would have like these three things: initialization, condition, and increment. These three things would happen inside that for loop, and that for loop would be repeated that many times. Means each time it would start with like I equal to 0, then it would check whether it's less than, or then it would be incremented, and this cout part array I means like that ith part of that array would be displayed. And then so you could see like for first time it displayed 1 then 2 and 3 and 4 and 5. Okay, so it repeated for as long as it was less than or equal to 4. So it repeated for 5 times and we got like all the elements of that array displayed. Second way to use like for loop is with the help of vectors. So in that case of the vectors, we would be using like vector library. So vector then data type is something we have to include inside this angle bracket, then name of that vector, vector1, and then this thing. So same way we use in case of the like variables, but means over here we have to provide like data type to be like vector and then vector name and then this value. Once we have that thing, since we want to use this for loop in the form of like iterator, what we could do is we also need to define one more object over here called iterator. So it's there inside like this vector library. We just need to add this line vector in vector of int type iterator, vector iterator of type int, and it would be stored as object it. And what we are saying, so this object would like iterate over. So this is like iterator that iterate over all the elements of that vector. Okay, entire range of that vector. So active is something by default it would decide like type of that element inside that vector. If you provide it to be integer, then you need to be cautious. If I write int, then it would check. Okay, if it's int, then and then only it would go. But if it's active, then it would go inside all of those elements by default. Okay, and then I am just printing those values. Okay, so in some situation we could also write that thing as like means we could dereference it and we could means when we are like write it, we could also write it as like for loop integer it equal to like vector name dot begin and then I less than equal to vector dot end and then like this it plus plus, and then in that situation basically we would be like generating pointer and we need to dereference it. But in this situation we could just like print that iterator itself, and that iterator would give us like same value. Okay, so over here we could see like 10 11 12 13 14. So we are seeing like all those elements over here. Okay, printed 10 11 12 13 14. Next loop is in case of the for loop it would repeat means as long as that many loops are not completed, but we would not have like check or whether that condition is means certain condition is true or not. Means we would have initialization, we would have condition, and we would be having increment, but we would not have control over the condition that we would be adding over there. To have that control over there, we have a while loop. So why in case of the while loop, we would be again same thing. We would be initializing that counter, initializing I to be 0. Then while loop is where you would be checking condition. As long as I is less than equal to 5, less than 5, so it would repeat for like 5 times. And as long as it's true, means this condition is true, it would true, and then I plus plus. Okay, so I would be incrementing. Same as like that for loop is that I would have like better control over the condition that is being checked. And so this is like thing, and that's the reason true is I like printed for 5 times. Second thing, we could also use do while loop over here. So in that situation, what happens? First of all, we would be we would be initializing, and then inside do thing what we would be doing like means do, and then we would be like printing this thing, and then we would be checking condition. Okay, so means we would first do increment and then we would be checking condition, do this part and then a while thing. Okay, so that would be like do while loop. So in that way we have like 6 data types by default, and we have like on these 6 control statement. We have if else if, then we have switch case, then we have for loop, normal for loop operator, then for loop operator vector, then we have this while loop and do while loop. So we have like 6 control flows that we could use inside our program, and we could make our code as fast as possible. And best choice is like means try to avoid like if else if loop as much as possible. Yeah, so that's like a word of caution over here. So this is like fourth tutorial. Then fifth tutorial would be about arrays. So means we did use arrays, but I would tell you explicitly how exactly we could like define arrays. So for that purpose, again, we have inside preprocessor directive, you could include these 2 libraries, iostream and vector. Means inside standard template library, there is also a library for array. So I would get into that thing when we discuss that thing inside advanced CPP. But right now I would show you like how exactly array can be defined. Okay, So inside main function, we could just like type data type for that array name, then the square bracket, and then inside curly braces, we could like add all the elements. So basically over here, it's just that like we are saying, okay, we have defined C as an array with like 3 elements, and that would be of integer type. Okay. But over here, there is a no control over like how many elements would be there inside that array. Okay. Because that would be issue. Because if I add like some elements over here in that situation, and if there is no space available in that situation, we need to like restructure our memory space. Okay. And it would take like a lot of time. So that's the reason. What they do is like whenever they have to define array, they try to provide like memory allocation, memory requirement, so that they could allocate that much memory for that particular array. Even if like number of elements inside that array grows, we could like still have like enough space, and we don't need to restructure our array. Okay. And better thing is like means instead of arrays, we would be using vectors. So means we would have like better control over that. But yeah, I mean this is thing. So when inside that square bracket, we could like mention this thing. Okay, how many element I would need over there. Okay, so that way I would have like means I have defined array D to be of integer type with 5 elements. So that much space would be allocated, and means there would be no issues later on, even if I like increase the length of arrays if there were like 1 or 2 elements. Still, like my structure would not hamper, or there would not be like some sort of unexplained behavior inside my code execution. The next thing is this is like one dimensional array. When we have to define like multi-dimensional array, 2 rows, 3 columns. So that would be like this. This is the way using which we could like define this array to be like 2 rows and with 3 columns. So this is the thing. And when we have to read these sort of arrays, we would be using like this to operate over like i's and j's, and we could read it. Okay. So this is like standard vector iterator I and auto D. So it would like go through all of that elements. So basically same thing. I have created it to be like array. What I'm saying means I could still like read through that using this iterator I. Okay. And when I like save this thing, and you could see like 10, 20, 30, 40, 50. So this is the element that we are reading. Okay. So I is being displayed. So 10, 20, 30, 40, 50. So these are the elements that are being displayed. So that's the array. Means you could define array to be of like means unbound type, or you could just say, okay, this is the array. But means that's not a good. Means you could define array to be of like unbound type, but for optimization purposes, it's not good behavior. You would get like unexplained behavior. So it's always better to define array with like size. Okay, and then like this is like how you could write like multi-dimensional arrays. And using iterator, you could like read all the elements of that array, or you to read those elements, you could also use like for loop. I mean this what we call it, nested for loop to read through like arrays at like means elements at different level. So that's the one thing. Next thing that we should get into is like we have pointers. Okay, so now we have discussed arrays, and we also discussed vector a little bit. Now we should talk about pointers. Pointers is a really important concept in C++. So basically pointers are nothing but a variable pointer. So this is the way in which pointer should be defined. There would be like asterisk sign before that variable, and that says like, okay, variable A is a pointer, and like it's special, it's special type of like variable. It's a variable which stores the address of another variable. Okay. So for that purpose, you would again inside preprocessor directory, you would be including these libraries IOStream vector and using namespace string. Inside main function, you would be having like some variable B. This is like any variable, it could be any variable. And the reason I have added this variable B over there, just to show you that the actual pointer is stores like value of that means address of that variable. Okay. And so basically when we are like defining pointer, so integer, so we have to tell, okay, what would be type of that integer, and to give it like special means to identify that thing, we have to add like asterisk sign before that variable name. Okay. So integer asterisk a pointer a equal to add ampersand b, that means address of b would be stored inside that pointer. So basically what we are saying, this pointer a would be pointing to this address b, and whatever value that would be written inside that address would be like reflected inside this variable a. Okay, so if I just print means a, I would just get like address of b, but if I like dereference that pointer, I would get value that is being written at that address location. Okay, so that's the thing you could see, like means when we print that thing. And next thing is, why do we need that thing? Okay, why do we need pointers? Means there is one more thing related to pointers. We could also use pointers when we have to define or we have to use memory inside heap memory. There are two memories, okay, stack and heap. The stack is like a kind of like memory which is used means at runtime, and then heap is which is like a dynamic memory, and we user or programmer explicitly has to tell, okay, this is the part of memory that I have to use, and to allocate that thing, instead of using this ampersand, we would be using like new variable that says, okay, this is the part that this new, and then you if you want to use like int, I mean, if you want to allocate memory for integer, we could say, okay, new int, new float, or new double, or new any object type, class object, or something like that. And whenever we have to delete it, we have to delete it using delete variable, delete keyword. Okay, and this now we have like this arrays over here. Okay, so I would try to read through them. So basically I believe like I just move this array concept over here, so this thing is really not needed for this tutorial. The bottom part where I have explained this for loops and everything. Why do I have like this rates? Let's see. What's wrong? Nice. It's working. Must have been semester. Okay, so you could see. So pointer is the variable which stores the address of another variable. So when we like display variable a, so you could see like this is the address that we have. Okay, so based on like system, so it's means hexadecimal format. So we have like this 8 and 12 elements over here. So based on that, you could like make sense of that. And then when I dereference it, I could get value of b to be 0. Okay, so this is a pointer that we have. Next thing is the vectors. So now we are taking it one step further. So vectors is like as I defined. So arrays are like means kind of cannot be expanded, but vectors are like something can be appended further and further and further. More element can be added to that. Okay, so we have to include this vector library at the top for that purpose. It's not part of like standard library, at least for now. And then using namespace std, and then we would be like adding this some functions over here. Okay, so I don't think like we would need this. Anyway, so basically this is where I have like defined 4 functions, and this function is just to like print vector of like type integer and name v in. Then I'm taking like assign function, pushback function, and emplace function. So basically on vector there would be various operations that can be performed. First of all, we are just like printing vector. Okay, and for that purpose we would be using this for loop and that iterator. So why to print vector? So this is where you would also understand how exactly function can be defined. For function to be defined means whenever we have to use function inside code, at the top means before main function we have to declare the function. So output data type, then name of function, and all the argument that we have to provide, we have to add over there, and then on this semicolon we have to end it, and then that there would be that function. Okay, and then we have to define that function after main loop, or before it's fine, but after is also okay. So we are defining this function. So void print vector this thing, and inside curly bracket we are saying, okay, what all operation will be done on that v in. Okay, so first of all, what we are doing, we are creating like iterator object of id, and then using for loop we are iterating through all the elements of that v in. Okay, So iterator would begin from like vn dot begin. So basically we are pointing to start location of that vector, and it would go until it's not the end of that vector, and then we would be like iterating plus plus it, and it would be like postfix type of like prefix and postfix type of like increment thing. But I would also show you that thing, what will happen when we have like prefix and what will happen when we have like postfix. And here, since it's a pointer, we need to dereference it so that we could read this element. So this is how we would be like printing vector. So whenever we have to declare function, first of all we need to declare it, and then we have to define it. So for declaring, we have to mention output type of that function, name of that function, and argument. And inside curly bracket, we have to mention what all things would be there, and we could also mention return type. Okay. So in case of the vector, there would be various functions. So for that vector, we could also assign elements. Okay. So I mean, we could assign first element that we provide from the console. Okay. So one to be like in. Okay, sorry. In is something we are providing over here. Okay, as a like some sort of object over there. Okay, in some sort of argument over there. Okay. So whatever value in would be added at location one, and then we could just print that vector. Second thing would be pushback function. So there are certain operations. Okay, assign is something would assign value to that particular location. Pushback is something would like assign add new element at the end of the vector. In place, same thing. Means you could like add that vector to that particular location. Insert would be performing same operation. Then you would have like operation clear, means clear the vector, erase, and you would also be having operation pop back so that you could remove last element of that vector. But I have added like few of them. So v dot assign 10 5. So I am saying like, okay, add these many elements over there. Okay. So when I print this thing, you would see, you could like see this thing. Okay. So you could see, so vector int of v int type. So first of all, we have to define vector because that would be provided as input to those functions. So I have defined vector v ints, and I have just defined it. Okay, I haven't added any values over there. Okay, using curly bracket. So what I'm seeing, assign like 10 values inside that vector of means with value equal to 5. So vn dot assign, so I could assign like those many values inside that thing. Second thing would be pushback. So using pushback, I could like or okay, so that's the thing. Then there is assign function. So assigning would just like, if you see over there, so what I'm saying, like assign just like one value to that vector. So that would also do same stuff. It means our vector size would be like different. Where is that assign function? Okay, so over here we are saying, okay, it would be size of 1, and that would be the case. Print v ints, but we haven't like printed that thing over here. Okay, then we have like pushback function. So pushback function is something, but inside each of that we have like that function. Okay, so after like assigning 1, printing the vector, it would just be 1. Pushing back 2 and printing the vector. So basically we have like this entire vector. Okay, and then you also need to understand that thing. Okay, so outside the context, this v ints is not getting changed. In the beginning we define v ints to be like means 10 element inside that vector with value 5. But with this second function, what we did, we changed it to size of 1 with value equal to 1. But when we run like next function, again it had like 10 values. We just like added like 2, means one more value over there using this pushback function. In place, we just like change like this value, one value over there in place function, and insert function we could like just add value where we want to add. Okay, so like first location value should be like 3. Okay, so this is something we have to define, and that value locate means we have to move our iterator to that location for in place, and then we could just perform iterator. Okay, so location that we want to, where we want to add it. Yeah, and that's it. So you could see like this 5 3 5, and apart from this place, we have insert, we have clear, we have erase, and we also have pop back. So last element would be removed. So this is all about vectors. Now we would try to learn about functions. So I also explained like what are the ways, but over here what I would like to stress over is like how exactly we could define function which are like called by value, and what are the ways we could define function which are called by reference. So let's get started. So as you know, like whenever we have like repeating syntax, so in that situation it's always better to go for like this thing, functions. Okay, so that because functions provide us like better way to functions provide us with a better way to abstract, create the abstract of our code. Okay, so that's the reason it's always better to what to write functions. But when we are writing function, there are various ways in which we could like provide argument to that function. Okay, and based on that, we could also increase the speed of execution and like means all of that stuff. Okay, so here you would see like two things: call by value and call by reference. So first of all, inside this preprocessor directive, we would be adding these two things like library that we would need, then using namespace std, so that we don't need to tell okay this is a standard library, and then we would be like declaring these two functions, increment and increment one. Even if you keep like it name to be like same, if we change like signature, I mean argument signature, it would have like it would be different function, but since we have kept it to the same. But first is like call by value. Over here we would be calling this function with value a, and over here we would be calling by reference, means address of means referring to the address of value a. Okay, so let me tell you. So this is the thing, and then this is the like one more function, increment 2, which would operate over arrays of length 5. Okay, over here we are just operating over one value, and then there is like another. There is one more function that would operate over arrays. So let's say we have created array of size 5, and then this is a one integer 4, and then we would implement this first function, calling function. So for calling function, we just need to use like function name and argument. So here we are calling it by a value c, and that value would be stored inside this variable d, because we have provided like output type would be like integer. So since value of c is 4, output should be like of like that value according to that. Okay, and then we have like this increment 1, and over here we are providing like value by like reference, so that thing would be like provided outside that thing. Okay, outside of that reference value. Okay, means when we pass it by value and pass it by reference. Okay, so whenever we have to pass it by reference, we have to provide like this ampersand sign before that variable name. Okay. And the reason we have to change from like call by value to call by reference is because let's say there is a variable a or variable c over here, and I want to implement it. But when I implement this function and when I like come out of this function, I cannot get like increment in c outside that function. And if I want to get that thing, I need to call by reference. So that's the one way to get it there. Okay, so I could get it like increment in c, and then there is another function increment to array of 5. Okay, so when it operator like this array b, so it would like increment each element, but I haven't defined that function. So yeah, yes, I don't think I have defined it. I think yeah. So that was just declaration, and over here I have like defined this return plus plus 8 plus plus 8 plus 1, and means just to like just so that we could understand, over here we are incrementing by 1 and over here we are incrementing by 2, and this is like to loop over all the elements. And then we have like this. So let me have a sip water. Then we are what we are doing is we are incrementing that element by 1, and we are again storing at the same location array I equal to array I plus 1, and we are displaying that element. And that's like this second thing. But over here, what the thing that you should be looking at it is like we are providing like array of size 5 over here. Okay, and when we provide that array as input to this function, entire array has to be copied into the argument, and sorry, and then it has to be incremented. means see, like you need to provide like two operations. First to copy it, and second increment it. But if I were means if I pass it as an like pass by reference, I just need to tell, okay, so this is like a reference to this array, and then I could just start from there. Okay, so I don't need to copy it again. That would save like a lot of space. So that's the beauty of like calling by reference. Call by value, it's good when you have like simple like arguments or simple integers or simple values. But when your data set get bigger, it's always better to call by reference. And whenever you want our data element to be affected outside uh, like span of that curly brackets or like this local region, you need to use this thing, uh, call by reference. So so you could see uh, sort of things I can turn inside. So when I implement this first part, increment C and increment, and when I like print out like D and E value, so value of C at the beginning is, oh, I implemented like this increment to be in there, okay, and I was printing those values. So it started from 1, 2, 3. So what I was doing inside increment 2, I was incrementing each element by 1, okay. So it started 2, 3, 4, 5, 6, and then we are displaying D. So value of D that is being stored over there is like 5, okay. And then we added like this thing C. So value of this increment 1 value is like 6, okay, because we started from there, okay. Because what we were saying, after this operation, value of this D is like this, and value of E is uh, okay. So increment 1 where we increase by 2, okay, plus a will increment by 1, and then addition 1 will be 2. So that's the reason we would be seeing it to be 6. So that is being done over there, okay. So this is a call by value function, this is a declaration, and this is a definition. This is like called by reference, and this is array. So if you have to like use this arrays over there, then it will consume a lot of memory, and it's a little better to pass it is by like reference, okay. And that's something we would see in like next tutorial. This is where we would learn about what are the benefit of passing array as a pointer to a function, so that we could save on like execution time. So over here again, passing arrays to function in the power pointer. So include this thing IO many and IO string, and then you would be defining 3 functions where array will be passed as a pointer. So over here you could see when you pass like normal value, then ampersand, and then this is like array. Array we have to pass it with like this asterisk sign. So array as a pointer, then array size means without thing, means just like array as array, and then array unsized. Okay. So these are the 3 functions that we have, and over here we have defined array of size 3 with these 3 elements 33, 16. Then we have called all of these 3 functions, and whenever we are call means whenever we have to define this thing, since we are like considering this to be like pointer, means we don't have to change anything much over in here. Okay, so means what we are saying, we are pointing to start location of that array, and we could just like means we don't need to copy that entire array to this argument location, and that would save on space. And array with like size array and unsize, so it's quite same. But what I want to tell you, like when we write this like that, execution time will be faster. I wish I could show you that thing, but let's see, how could I don't think like I would be able to. Would I forget? That's so let's try to run it, and G++ standard. C++ 11, then I have like 9, then output should also look like 9. My system slow. That pointer. Seems like my up button has stopped working. Didn't I save it as like, oh, -9. So you could see like it's like 33, 66, and 99. Can I see like execution time as well? Can I? Probably I need to use like time library to show you that thing. Okay, but the thing is that like means when I do this thing with like this pointer, so it saves because we don't need to save that thing again. Okay, so that's the beauty. So yeah, but three of them also work. Okay, when you point array, pass array as a pointer, pointer to the array. When you pass array itself, we need to copy entire stuff, like filling that coffee mug and just like passing as it is. Uh, and then third thing is unsize array. This unsize array is like very unhealthy thing. Okay, so we should not be going to that at all. Really bad. But yeah, that's the thing. Next thing is about class. So until now, what we have learned is we have learned about basic stuff about like, let me delete this. So we have learned about basics of CPP, means what would be like a structure of CPP, then how to define constants, then how to use get line to get like inputs from the command line, then what are the data types and control flows, arrays, how to define arrays, what are the pointers, what are the vectors, what are the operations that we could do on vectors, what are the function, what is the passing by value, what is the passing by reference, what is the passing by point and the form of pointer as a pointer. And then we have like class. So class is a way. So basically in this C++ programming language is something which supports object-oriented framework. Okay, and what does it mean is that like, what does it mean is like means you could perform various operations. Okay, means you could perform various operations on it like very easily. Okay, and you don't need to worry a lot on that. So in like precise manner, means your code would become modular. That's the beauty about this object-oriented programming. So and whenever we want to like write code in the form of like object-oriented programming, the first thing that we should be aware about is how to write classes. So classes is the way which would allow us to implement all those principles of object-oriented programming inside our code. First element is like abstraction. Second is encapsulation, but it means I would go in a way so that you could understand. First way is encapsulation. Okay, so encapsulation is like encapsulating all those elements that we would be needing for that particular class. So this is a main file. I would be like using doc class over here. Okay, this is how we would be like uh, using like doc class over here. So I would go to just that doc file, doc header file. Okay, so first of all, what I would be doing is I would just be encapsulating all the element that I would be needing. So whenever we have to write class, the first thing that is we would need like two things. Okay, first we would need like header file that would be saved with that class name with HPP extension, and over there we have to include hash include IOStream using namespace STT, and we could also include inclusion guards over here. Okay, like hash if not defined. Okay, if not defined means hash if not defined. Yeah, this thing, this macro. define, and in the end also you need to just forward whether that should be before. I think that should be there, and that should there should be like this and syntax should be like this. So this is the syntax that we would need. So basically what we are doing over here, so for that means for a whenever we have to define class, we would need like two files for that class. First we would need a header file where we would be including these libraries. We would be using this standard library, and we would be including this inclusion guards. And what it's saying, if this dog file is not included, when it goes to like main file, when it's reading it, then include that file during pre-processing stage. Try to expand it. Okay, include it if it's not defined. If it's if not defined, then define it means include it, and this is the syntax to define it. And at the end, like okay, end. Okay, yes, when it's done, and then we would have to declare our class. So for class declaration, we would start with like this keyword class and name of that class, and inside that thing curly bracket we would have like entire thing. So we would be having some access modifiers over there. Inside class, all the element by default would be private. That means only user could access those elements from within the class, not outside the class. So like the string means variable name string of name, and a variable of type integer with variable name license number are like private data type. Okay, these are private access modifier, means they are like private data types. Then whatever thing that would be accessed outside like this class would be like public, and we need to tell them explicitly. And then so we need to write this public, and then after colon we need to tell this thing. Okay, so we would be like defining declaring some methods over here. And means methods are nothing but we could also like declare variables, define variables, and we could also declare methods. Okay, methods are nothing but functions. So these methods could be like default constructor for our class. Okay, means how exactly our initial values of the class should be initialized. It could be copy construction. It could copy constructor means you could provide like some values to those elements that or the variable that would be used inside the class, like to name and to license number. We could also be using like this some custom class methods like set name, get name, and all that stuff. And we would have like some classes like void that would just to like print info, and like means to do a lot of other stuff. So basically there would be like header file. There would be three things. First, like this include library. Second thing, inclusion guards. And third thing would be declare class and include all the methods that would be needed according to the access modifiers. Okay, private or public. And then there would be like .cpp file over there at the top. We need to include that. Okay, we need to refer it to like okay hash include doc.hpp something we have to include, and then we would define all of those classes. Okay, so this thing is we have to keep in mind it belongs to like doc class, and then set name is like that method name and output data type, and these are the arguments. And this name in would be like save in this variable name. Okay, because this name is like private variable. Okay, for our class. So these are the method that are there, and we could also return those things. Okay, since it's like get name method, we could return get license number return, and it just like print. Okay, so we have this dog class, and what basically we are doing over there, we are like setting name for like that dog, and we are also adding like some license to a license number to the dog. And whenever we want, we could also get those names. Okay, and this is like this is how we would define class. Need two files, header file where we would be adding libraries, inclusion guards like this if and if defined, and then actual class definition where we would be defining all the methods and data. And then we would be having like .cp file where we would be defining all the methods in detail, like what would we do, what all operation we would be doing on those variables, and what we would be returning. And this thing, the dog class is like encapsulates formation, means inside that one dog word or dog class we have encapsulated all these information like this, all these data elements, all these methods, and or all those functions. And with this just single dog word we could like change a lot of things inside main function. Okay, so when we say okay dog, so from that dog class we could create object, and creating instance of that class is called as object. Okay, instance of that class is called as object, and here we are creating two objects. Okay, dog1 and dog2 means using this format we would be able to encapsulate this entire information in this single word. Second thing, second principle of object-oriented programming, that's like abstraction. With just that single word, we would be able to get that entire information inside this dog1 and dog2. So that's the abstraction. And third thing is we could access those method directly. Okay, from dog1, I would be setting name of my dog2 Trixie. For dog2, I would be setting name to be Kali. And for dog1, I would be setting license number to be 1, 2, 3, 4. And for dog2, that would be this. And then I would be printing info for dog1 and dog2. Okay, and then I would be returning 0. So this principle of like this encapsulation abstraction and becomes very easy. And this is also example of polymorphism. From same class you would create like two different objects, so you have like multiple mobs of same class, so this is a polymorphism. And from that class you could also create like child class. That syntax would be quite similar. You just means whenever you are like defining this dog class over here, so you just need to tell like okay, public, and maybe let's say we have like some another class. Okay, but you need to be sure. Okay, child dog, and you would be referring it to like dog means class dog. Okay, so child dog is like my child class, and dog is like my parent class. And from that I could create like child class, and it would have like all the properties of that dog, which are stored inside this public modifier, like these properties. So this is where you could like create like these child classes, and that would be property of inheritance for the classes. Okay. I just okay. So that's the thing about class. So first thing, whenever we have to write class, two files, header file where we would be like declaring all the variables and methods. Second thing, class definition, a CSV file to define the class methods. And then third thing, inside main function, we will be creating instance of that class and object. And from that object, we will be calling all these stuffs and getting that thing done. Means one more thing about these classes is like we could also create like this object in the form of pointers. Okay, so like dog means this method itself we could create this as a pointer. Okay, here we are just creating this object itself. Okay, but we could also create pointers for these classes. And in that situation, instead of using this period symbol in between like this dog1 and set name, we would be using this symbol. No, not this one. So using this arrow symbol, we could like go inside like these methods. But for now, at least I would just run it, and I would show you like means what means whether we are able to run this thing properly or not. G++ standard. This is a class 10. Dog set name standard. What did I do? So I figured out that issue. Okay, that issue was about so whenever, so since this is a class, so for class means in first tutorial itself I mentioned over here. Okay, so whenever you like write this thing, format should be like main file name and class file name. So we did not add like class file name means over here, means up here. That's the reason we just tried to build it with just like with class file name g++ standard C++1110 class.cp dot. In that situation it did not work because it did not understand like where to reference dog. Okay, and because compiler did not understand, for that purpose we also need to provide like class name over there. and that thing is like 10 class.cpp dog.cpp. So this is a class file name that we need to provide over there, and then compiler understand, okay, where exactly it should reference to when it say, okay, use this object dog or like class dog. So it understands, so it builds, and when I like run this executable, I get these two names. I set like dog name as a tricks and license number to that, and second is like when I'm printing all of that. So means this is how you could like create like classes. You could follow all the principles of like object-oriented programming, encapsulation, abstraction, polymorphism, like multiple instances, and you could also get inheritance in the term of like child classes. Then there is a one more thing that we means there is one more tutorial that would be like 11 tutorial. So in case of the C++ programming language, we could also do one more thing is like we could also overload our means function overloading is quite common, because if we just change argument inside like our function, means even if you use like same function name, and even if you just change argument that are there, okay, means if you change from like integer to float, in case of generic programming, still we would have like different means signature, and means we could like overload that function. Okay, so that is the function overloading. But in similar way, we could also do overloading for operator. Means we could, since we have like plus as a like operator to do like addition between two integer values or like float values or two digits numbers, we could use that operator to perform some different operation, okay, inside classes, and that's called as operator overloading. And for that purpose, we have to use some method. So over here I have a class called shape, and inside that shape I have this private method. I have like two like a variable defined, length and width, both of them are in like integers. Then inside public I have like defined like this default copy constructor. Actually it is not default. So default constructor is one where we would be like uh, giving like some default values to this variable, okay. But over here, so this is kind of default, but I mean we could like change them as well, okay. Since we, if we like remove this L equal to 2 and W equal to 2, it would become like copy constructor, and it is a copy constructor actually. But over here we are providing some values to this variable that are there inside private part. Yeah. Private modification access regime. Okay, so this is like copy constructor, and it should have like same name that of like class. That's like compiler generated functions. We don't need to define them. It's just like the traditional practice. So we define like len to be like 2 and width to be W, and then we are calculating area. This is like another method. Now return type should be double area, and then argument we are not providing any argument because we are using this variable from like this private access part. So length type width, and we would get like area. But thing is that once we get like area of that rectangle or whatever it is, what we are seeing, there is one more method, and that is like this is like operator overloading. Okay, so this method is in the form of like plus operator. Okay, so this plus operator would act as a method, and that would perform like addition between like two areas. So to define that operator, what we would need syntax integer, means output type of that method, and operator is like keyword, and then that operator itself. It could be plus, minus, equal to, or whatever symbols that we have, and then we would be providing argument, and argument would be shape in. So means we are providing like shape class itself as like argument to that operator, and inside in here we are providing like addition between area of that our actual area over here calculated using this thing, and over here we could also use like this function over here, okay. I mean this pointer, but provided we have to create like shape as like pointer object in first place. In that situation we could use like this pointer to point to our own area, and then point area of that this another rectangle uh, object of name shape in, and we are getting that area, and we would perform like addition between these two areas. Okay, there is not much logic behind this thing, but I'm just trying to tell you, okay, whenever we do this means just plus operation, we don't need to explicitly perform area calculation for this and then area calculation for that, and we would directly get like addition of these two areas done, okay, just with that one symbol. So this is like class, and over here we are declaration and definition are not different. They are done in like one class, and this is the main function. So we are defining like class, means first instance of that class to be like sh1, and providing length to be like 4 4, length and to be 4 4, and second to be 2 6. and over here I am performing like addition between them. Okay, so 4 by 4 is a 16 and 2 4 is like so sh1 plus sh2. So this addition would be performed, and then like these results would be like sh1 area, sh2 area, and 2 area. So you could see like these results. I don't know, I have like written 0 twice, so like delete one. I save it and just run it. I don't think like I had tested it before yesterday, but let's see. I don't need to add like everything in there. In there. Okay, so shape area, first area shape is like 16, another area shape is like 12. So 4 by 4 is 12, and summation of these two areas like means sh1 plus sh2. Okay, so it's performing like a like summation between these two things. Okay, so that's the thing, and yeah, so what we could also do is like instead of doing this thing, just calculate area for sh1. By default it would be no, this thing is being done. It's just that like means we don't need to write it to be sh1 plus sh2. Means even if we just like okay, but this is the way actually sh1 and sh2. So we are getting like summation of these two areas and the table like 28. Yeah, and we don't need to like perform these things separately for each of that class. Means since we have like what we are saying like sh1 is like sh1 is just the object. Okay, it's nothing because that means inside this default constructor we are not calculating area. For that purpose this area method has to be calculated separately, means activated separately. But when we so when we like use this plus symbol, this plus symbol consider sh2 and it calculate like sh1 part as well, and then it add like sh2 to that. Okay, means area of itself and area of like this sh2. Okay, is the thing that's being provided as input to that. Okay, and it sums them together and it gives like area of 28. So it's working. So basically this is operator overloading, and from that you will also understand there is like means for this same class, if you provide like different argument, we could like get this function overloading. Okay, and that's the function overloading, and this is something would lead us to like generic programming, and this is where we would be using templates. So there would be templates that we could use, and I would walk you through that code if I have that over here. Okay, yes, that explanation that I added. So inside C++ functions, then we have classes, overloading, function overloading, operator overloading, templates. So inside general for generic programming, since if our argument change, still we would need to write that function again. Okay, and to avoid that writing again, what we could do is we could use templates. And for that purpose, there are two templates. Okay, function templates and class templates. For the function templates, we need to write template type name t, and these t's or u is multiple things. And inside means when we are like trying to define that data type, we need to use t or u instead of like that particular data type. Okay, and that way we could like define our class the way we want, or like function the way we want, and means whatever argument we want, we just need to write that code once. And for same for classes, we don't need to write class differently, we just need to add that template. Okay, template class t, and it would work. And for like, and whenever we have to call that thing, so class name, and then over here means after class name inside angle brackets we need to tell like type of object, and then object name, and it would like work. Then there is inheritance and multiple inheritance and access modifiers, child classes, so that's maybe soft polymorphism pointers. There is one more thing, there is a virtual functions, and but virtual functions before that there is a friend method. Okay, so friend method is, so we saw like means when we create child class would only access elements inside parent class which are under public regime. Okay, if you want to access some elements which are inside private or protected areas, in that situation we need to define that method inside parent class to be like friend method. Okay, we just need to add a friend word in the beginning of that method. Okay, friend wide. Okay, so that's the thing. And then there is a virtual function. So when we create like this point means object from particular class in the form of pointers, and when we try to assign some, means allocate, or like when we try to connect that object with some method inside that class, and if we do it like repeatedly, what happens in a second, when we call it second time, it would like overrule it. Okay, so when we want to make that binding between like that object instance is object type of that particular class instance, and that method a dynamic, we would need to use like this virtual method. Okay, virtual functions. And then the static variables, so this would remain same across multiple instances. And then there's a global variable testing code strings. Yeah, this is the template thing that I was saying about. So this is a template thing, and then there is a prefix. So I believe like we are done with like most of the things. So and just there is one thing that I want to discuss about, and that's like this prefix and suffix thing. So there is a prefix thing and suffix thing. Okay. So let's say we have initiated any variable to be like 2, and when we like write plus plus a, that means like prefix. So basically, what it does is like it would okay. Let me first run this thing so that you would understand it better. So see, so I have like a as the same as a 2. When I print plus plus a means I have added like prefix operator. So by that logic, I should be getting value of, means I'm getting value to be like 3. Okay, that's valid, because when we use like prefix operator, what happens? We are creating means what we are doing is like we are creating copy of that variable. Okay, we are incrementing it, and so let's go there and see what I have written. I believe I have written somewhere. Yeah. So difference between prefix. The prefix operator increment the value of the operator or variable, and then return the reference to the variable. So that means, first of all, in case of the prefix operator, value of the variable would be incremented, and then that we would be providing reference to the incremented value. Okay. So first we would increment a to like 3, and then we provide reference to a variable a, and that would give us value 3. Whereas in case of the postfix operator, we would create the copy of our variable that would be incremented. Means not copy, we would be creating copy, then our variable would be incremented. 3 would change to 4. Then we would return our copy with initial value as a return for the time step, and then next time instant we would get like this before increment. Means then we would return another copy, which would be like our postfix thing. Okay, so if you see like this thing, so over here after this first prefix operation we get 3, because we incremented a by 1, we get 3, and we return reference to that variable a, and which has value 3, so we get 3. Second time we publish a as it is 3. Then we do like postfix operation. So over here we create the copy of a that would have value of 3, and then we incremented it. At this time, if I publish it, I get same value, okay, 3. But at next time instance, when I do this thing, I get incremented value of a. Okay, because at this time instance, they just create value of a and they return it like 3 to be 3. And once that operation is complete, 3 would be incremented to 4, and then a value would be 4, and that would value would be like written at next time after the operation, that will be 4. So if you want to, so this is something matters when you are doing like this for loop. So it's always better to use like prefix over there. Okay, so that's the thing. Next thing is struct. Okay, the struct thing is something important. Let me see since in this call. We are like almost done. There are like just two more things that need to be done. First is like this struct variable type that I want to explain, and second thing is Cmake list and test operation. Okay, so once these two three things are done, we could go and means conclude this session, and then from tomorrow we could talk about this thing, what advanced CPP concepts that I would tell you briefly about. You could also check them out over here in chapter 2 and chapter 3. Basically, it's about compiler generated functions and smart pointers. But I mean, this basic part is supposed to be known first before going over there. So this is a 14 tutorial, and this tutorial is about how exactly you could use like struct data type over there. Okay, means we know like we can define class and it could include both data types and methods over there. But then second is like struct. Struct would just include uh, data elements in there. Okay, so they could like group all the data elements together and we could include them. Okay, so enum is like one more thing. So basically, it creates data means data type of like type color, and it could give value red, green, blue, and means that's like type to create custom data type. So we have created custom data type of color. That is one way. It has nothing to do with like struct. And then there is a struct which would encapsulate multiple data elements together, and that would be saved inside this single struct called data, and that we could access later on. And this thing become important because in case of like simple for column filter implementation, we might need to store data related to vehicle in like one struct file, and that's when this become important so that we could access it effectively. So for that purpose, what we are doing over here, a syntax is like struct is a keyword, and then name of that struct data. Inside curly bracket, we could define all those elements, and inside main function, we have to create instance of that struct file or struct thing. So that would be like data one, and we could read element like a using this syntax data one dot a. We could read it. We could also like use means data one dot a. We could like read element to be 10. So when we and here red, green, blue, it would give us like 0, 1, 2. Okay. So when I run it, so you could see like 0, 1, 2, and value of data 1 dot a to be like 10. If I change it to be, that would be like 20. But yeah, means this value is something you could return. That's the reason we need to learn how to use struct data type. And then we have like this test. So basically inside we learn like means first of all we need to learn about code editor, debugger, then so this something can also act as like debugger. Okay, so there are like various tools that we could do. I mean, toggle breakpoint, new breakpoint, enable breakpoints, and like start debugging and all that stuff. So basically, it would also act as a debugger. The second thing is like compiler G++. Then we have like make as like build tool so that we could build our code, and then Cmake, which we act as like configuration tool. Then we also need to learn how exactly we could test our code, and for that purpose we could use like Gtest library, and this is the way you could like use it and define it and test it. Okay? So first of all, whenever we have to use Gtest to like run particular test cases, what you have to do is in the beginning you have to include Gtest slash gtest.h at the top. Okay, you have to include that library, and then you have to start defining those test cases. Okay, so here we don't have like main function or something like that. We directly start with means we do have main function, but before main function we do define those tests. Okay, so inside preprocessor directly inside only. So we write that thing, and then we define test to be like test, then name of that test and name of sub test. Okay, and then inside that test we have like various condition that we could just assert eq is it means like assert equality. We also have like expect qq. So eq means equality, and assert means check value 1 is equal to value 2 or not. Assert means it's like strict form. Okay, and if it's not equal then give failure. If equal then okay. Expect means you could means it's kind of like you could have like some value, I mean some difference over there. Okay, but that's the expect eq thing. Okay, means it's not that strong form of like testing. But assert eq, expect eq unit means there are certain situations where you could write assert eq, for those things which are like safety critical and which are like means can be ignored, you could write it to be like extra deeply. So syntax will be first write this library, then test name of that library, sub name of that test and sub name of that test, and then we have like this expect EQ or assert EQ, and both first thing is expected value and then actual value. So expected value is like actual square root of that function, and then you call this actual function and 30 root square root of 36. This would give us like actual value, and you it would compare these two things. They are same. It would say okay, that test is pass or not. Okay, so this is like these are like first test. This is the second test about like negative numbers, and then there is a main function. Inside main function you write like this int argc and char star star arg v. So basically, so that you could like change arguments and all that stuff from like main function itself. Yes, while compiling that thing, that would be necessary. And then you add like this line about like testing and init Google test and returning run all test. So basically, this is the syntax that you have. Okay, and means it would this is something would like help you to like run all those tests. Okay, but if you want to build this thing as it is, it would not work. Okay, and for that purpose, what you need to do is you need to use cmake file. So I have added like the cmake list.txt file over here. Okay? Because to run those test cases, you would need Gtest library, and we don't have Gtest library over here like directly. That's the reason you would not be able to run this test directly from command line. So for that purpose, or terminal, for that purpose, what we need to do is we need to build it properly, and we need to like link all those things together properly. So first of all, cmake cmake thing is cmake minimum version, cmake minimum required. So it would expect us to tell the version required, the project name, then find a library that you need. In our case, we need Gtest required, then include directories. So Gtest directory includes directory. So basically it would include that directory. Just keep saying this dollar and this thing, that means it is a variable inside like this Linux work system. Okay. So this is the way to get like this value of that variable. So this is the name Gtest include dirs. So basically this is a value, a variable inside bash file, and that value can be accessed using this dollar and inside curly bracket that variable you could get that value. So include directory. The next thing is you need to add executable. So we are saying okay, run this file 13 test.cpp file over there, and then save that as executable run test. This is add executable, and then what we need to do, we need to link it to our Gtest library. Okay, because over here we would be getting some object codes. We need to link them with like Gtest library, and then we would get like five final target file. Okay, so target link libraries on this run test, then our Gtest libraries, and then this thread. Okay, so basically it's like this is the syntax that we would need. And Cmake is the thing that you should keep in mind always is like means even for host, you would need like Cmake minimum required, then you would need like project name, you would need like a find package, Gtest required, and then this include directory would vary. That might not need all the cases, but you would need add executable. Then you would need this target link library, so that you could like link this these various executables together, and you would get like final target executable. This is a cmake file, and using this cmake txt file, we would be running this 13.ts test.cp file. Okay, so let's see how can we do this. So for that purpose, we need to go to current inside that folder, and we need to like cmake space period. That means like current folder. So this command would find cmake list.txt as the current folder, and it would be lit. Okay. So it has found that thing, and it has created a make file. Okay. So you could see like a make file has been created. Means even if it was not there, it would have been created. Once that make file is there, you could just like type make, and it would find make file over there, and you could see like it found that, and it would build the target, and now you could run that target. Okay. And over here you could see okay, it ran like those two tests, and both of them were like okay, and means this entire environment is like all the test cases have been passed. So that's all about like today's session that we plan. So this is how you would write test cases using like this Gtest, test one test, and you could include like as many tests as you want, and you could like using Cmake txt file, you could just run them. So this is all about that we planned for today. Okay. So if I have to summarize what we saw today, so first thing that we saw today was like basics of programming. Then we learn about types of programming and interpreted compile languages, the process of compilation, code structure is something we discussed. Then we also discussed C and C out, get line string, string namespace, macros, and inclusion brackets. You could also read it out. Then we learn about like operators that are there, arithmetic operator, assignment operator, relational, logical operators. Okay. So I don't think I have added any like separate tutorial regarding that thing. But thing is that like using there are like arithmetic operators. Okay, this addition operator, subtraction, division, or modular operator, the arithmetic operator. Then there are like relation assignment operator like this. These are assignment operator, okay, which assign value to variable, and then are relation operators, less than, greater than, equal to, and logical operator like double ampersand for and, vertical bar for or, and like for not. There is like this thing, very not operated in the form of where is that? This is like or operator, and the not operator itself is like not word itself. It seems like I haven't. Yeah, this thing. So this is a not operator. Okay, this exclamation sign is a not operator. So we learn about that. Then we learn about control loop. Then we learn about functions, pointers. Then we learn about arrays, then classes. Then we learn about overloading function, overloading operator, overloading and templates, then inheritance, polymorphism, then virtual function, friend methods, then iterators, static variables. Then we learn about global variables, then testing the code with the load Gtest, and then how to like Cmake list, means how to use build tool like Cmake list, Cmake and make. We also learn about good compile using G++, and for optimization, strings input and output. Means basically there is F string and H string. So basically these are the things using which you could like take string as input and you could operate over it and you could save it to some file. So whenever you have to like read some document, you could use like this thing, F string string, but that's simple. That's like basic part of C++. And then optimization, whenever you have to do optimization, whenever you want to execution to be done faster, we could just add this like -03 over there, okay, this tag, and this tag would like increase execution time. It would speed up the execution. It would make like small angle approximations, and yes, it would know like deeper into like those decimal points, and that would like speed up the execution time. And this is about how to run like cmake.txt file to run any code. Okay, means we have added the cmake.txt file for that, means this thing for our test.cp, but means you could like means find packages and all that stuff. You don't need anything over there. Okay, you could just like means add executable, and you could just add that thing over there, and you would like get that thing running, okay, very easily. So means CMake list, you get make file, and then eventually you would get uh, like make file, and that you could run, and you would get like everything. Then virtual control for Git and GitLab. There are and then there is a coverage analysis. So basically, coverage Gcon is a tool which we could use. We just need to run Gcon instead of a Linux terminal. I don't have Gcon installed, so I cannot show you that. But it would give you HTML file. You could like open it in the browser, and you would see like this total part of your code has been uh, checked and not, and that's the coverage analysis using the control. And then last is the version control. So version control is something would allow you to have like better control over the version of your code. Okay, means multiple people could work on same code. Okay, they could have like same copy of the code, and they could develop individually. And then basically Git is like version control tool. Means it grows in the form of like trees, branches. So there would be main line, main branch, then there is a development branch, and then there's like individual branches. So main branches where like your actual code would be like production code would be there. Then there is development branches where like everyone would be pushing their code, and then there would be individual branches. So individual branches is where you would be adding like you would be doing your development, you would be adding your thing, then you would be committing your code, yes, staging and then committing, and then you would be pushing over there, and then you could be pulling it from there. Okay, so you have like two things. You have like this form of yeah, so this is like remote repository, and on my system also have like this local repository. So basically, we could do like push pull between them, and we could also merge. Basically, it's a version control tool and Linux and Bash file. So these are the things that once we are like comfortable, we are like pretty much okay with everything to handle C++ in advanced form. So tomorrow onward, we would go into like this advanced like topics that are there inside like C++ coursework. I think I shouldn't be like opening them, but I could just tell you means this advanced CPP, then compiler generated functions, and then like other things are we would be like doing later on. So we would so this is the basic CPP that I would recommend, like try to go through that, try to implement all these functions and all these code by yourself, or run them and see whether it works or not, and try to understand from that. And then once you're like comfortable with that, we would like tomorrow I would give you like second session regarding compiler generated function, like all this rule of 5, rule of 0. Then we would talk about like resource acquisition with initialization, that's like smart pointers. Then we would also talk about STL standard template library. We would also talk about templates again. We would talk about meta programming. We would also talk about expression templates, callables. We would talk about parallelizing. That's like threading. So we would talk about all those things tomorrow. I hope like I would be able to finish all that stuff today and like create some like proper tutorial for you. We would be doing that thing tomorrow, and once that's done, tomorrow, maybe day after tomorrow, we would do work on project related to Kalman filters using that. So I would give like small session related to Kalman filter, extended Kalman filter, unstandard Kalman filter, and particle filter, and then we would implement that using C++ programming language. And then later on, if you get time, we would do sensor fusion. So that's all about this session. I hope you find it useful. All the best, study well.